So the new unit today is about quadratics. Do you know that quadratics are like y equals x squared, and they have a curve like this? Raise your hand if you already have seen them and you know them. Okay, good. Then you just need to know a bunch of terms for today. Like, for instance, that one spot at the bottom, like the lowest spot of them all. There's a name for that. Do you remember it? Yes. Close. Vertex. Apex is like, if it's flipped upside down, it's the very top of it. You could call it the apex then. But this is called the vertex. Please write this on your iPad because it'll improve the probability you remember that word, since only one kid seemed to know it. Vertex. Next, I'm going to make a dotted line that runs right down the middle. It's called something. Now, some of you are going to say a line of symmetry, and you would be close. It's at an official name that's slightly different than that. Yes?
Asymptote?
Nope. It looks like an asymptote, but it's not. Asymptotes you can never touch. This one touches it, so it's not an asymptote. It has to do with symmetry.
Symmetry.
It's not just a line of symmetry. It's more complicated than that. It's a axis of symmetry. Axis of SYMM is good enough for me. The axis of symmetry. Okay. Is that everything that you need to know about a quadratic? Nope, we still need to know more stuff. A lot of times they touch the x-axis, and that's called the x-intercept. Would you agree that this one seems to touch the x-axis, like right there? That's called the x-intercept. It also seems to touch the y-axis slightly higher than the x-axis there, but this one's not super clear, but it is definitely touching the x and the y-axis. Those are called the x-intercept and the y-intercept. I'm going to see if you are smart enough to know this already before I even teach it to you. If you're really good at this, you could tell me the x-intercept and the y-intercept of this.
Attention students and staff, this is Mr. Henson. We will be conducting a fire drill momentarily.
All right, so we're back, and this has got two x-intercepts and a y-intercept, and one of them is easy to find, and one of them is harder to find. Now, let me give you a sentence that I think you should memorize. The x-intercept is where y is 0, and the y-intercept is where, what do you think?
X is 0.
X is 0. Okay. So if I wanted the x-intercept of this thing, I would set y equal to 0. And at first you might be just like, well, I don't know what that does. But then I hope it kicks in that in algebra you learned that this part could be 0 or this part could be 0. So x must equal -3 or x would equal 4. And that there is your x-intercepts. Do you get how I did that? I set y equal to 0, and then I just solved each little part. Because see, if I put a -3 here, this part becomes 0, and 0 times anything is 0. Even if I put it here, of course, sure, that doesn't turn into 0, but that's okay because this part's 0, and the whole thing will be 0. Do you get that's how to find the x-intercepts? Okay, so then how do I find the y-intercept? Y equals x minus 8, x plus 1. I can find the y-intercept super easy. Let me say the sentence one more time. The y-intercept is where x equals 0. So you stick in x equals 0. Does that mean the whole answer is 0? No. No. X is 0. X is 0. Y equals -8, still in a parentheses. 0 plus 1 is 1, still in a parentheses. So what's the answer? Y equals -8. What did I just do? I stuck in x equals 0 because I was finding the y-intercept. The y-intercept is where x equals 0. So do you get -8 is the y-intercept? Now, if I had shown you that on a picture, all of you would have been like, well, duh, the y-intercept, you touched the y there. Like, it's easy to see the y-intercept when they're written like that. The x-intercept is these two. I'm making red dots. And the y-intercept is there. Well, on a graph, you just look, and there they are. But on an equation, it's a lot harder. I'm going to give you one now. See if you get this. Y equals x squared, just that. What is the x-intercept? Don't say it out loud. What is the y-intercept? Don't say it out loud. The x-intercept, you put in y is 0. And the y-intercept, you put in x is 0. And I hope you can solve those. So if I put in y is 0, 0 equals x squared. So what's x equal? 0. On the y-intercept, x will be 0. So I put a 0 here. And now I have y equals 0. Oh. So 0 and 0, oh, that's because, think about it. Think about what y equals x squared looks like. It looks like that, where it touches right there. And that's the only spot on Earth where the x-intercept and the y-intercept are the same exact place. The x-intercept was at 0, 0, and the y-intercept was at 0, 0. Okay. Will this still work if it's a more complicated equation? Yeah, it will. Watch. What's the y-intercept? I said x equal to 0, and I can do that in my head. Y must equal 7. Now some of you are like, well, I knew that because it's at the end. Is that always going to be true? No, watch. This parabola has been shifted 3 to the left and up 8. Do you remember the last unit we just did? Does that ring a bell? 3 to the left, up 8, right? Okay, what's its y-intercept? It's not 8. Talk to the kid next to you about what to do. To find the y-intercept. The y-intercept is where x is 0. Y equals 0 plus 3 is 3. 3 squared is 9 plus 8. Who had 17? Raise your hand if you had 17. Awesome. Good. See how it's not that bad to find x-intercepts and y-intercepts? The x-intercept, you stick in y is 0. Y-intercept, stick in x is 0. Could we have done that on this one? Yeah, we could have set this equal to 0, but it would have been a lot harder to solve. I could have put the 0 over on the y. It would have just been a lot harder to solve. All right, then I'm going to leave you with this. If I gave you a picture and it had a parabola like that, and it had a dotted line like that, and it had a big bright green dot like that, what's the green dot called?
Vertex.
The vertex, and it's right on the what of what? Axis of symmetry. Does this thing have, if you go up high enough, does it have a y-intercept? Yeah. Yes. And if I knew the equation, which we could figure out, if we knew the equation, we could find the y-intercept by setting x equal to 0. And if I wanted the x-intercepts, I can see them. They're right here. I'd have to be able to, they'd have to tell me what the numbers are on the graph, but the x-intercepts are these two dots right here. And so if they were at, let's say this is 6, and let's say that this is 3, then I could even write an equation that goes like this. You see what I'm doing here? I know the x-intercepts are 3 and 6, so I just set up my equation that way. The only way that would get messed up is if I had a stretch factor in there. Don't worry, that won't come in for a long time. You won't have to do that for a long time from now. All right. Do you agree that that's been factored? It's in factored form. Do you agree that you could multiply that all the way out? Please do that. Everybody multiply this all the way out. I'm going to pause for a second while you multiply it out. You're going to get general form after you've multiplied it out. The one up here on the board was in factored form. What I just asked you to do is multiply it out, and I hope you remember this. You go first, make x squared. The outside ones, I'm going to use different colors, just color code this. The outside one makes negative 6x. The inside ones makes negative 3x, and yes, they can go together. And then the last ones make negative 3 times negative 6 is positive 18. And then I'll put it all together, and I'm going to say y equals x squared minus 9x plus 18. Raise your hand if you had that one right. Sweet. That is called general form. it's got a, b, and c. You remember that formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. It had a, b, and c. A would be 1, b would be negative 9, c would be 18. That's a, b, and c. All right? This form, that's called factored form. And there's one other form, and it's called vertex form, because surprisingly enough, it has the vertex in it. I pre-taught you this, so some of you are going to remember. What is the vertex of this? Who's got a good long-term memory? It's about a week and a half ago I taught you this. Take a guess. Say it if you know it.
8, -7.
8, -7. Very good. Now, if you're like, why did he change one of them and not the other? Why do we change this to positive 8? Because you don't trust the inside. Remember that deal? And you trust the outside. That's the vertex. See how it's so fast to find the vertex if it's in that form? That's what that form is good for. It tells you the vertex. Why is the vertex such a big deal? Because this parabola, I can tell you, its lowest spot of them all will be this. That's called the minimum of something, if it's the lowest of them all. I know the minimum already. The lowest this thing goes is -7. Because if this is the lowest spot, you know, parabolas always look kind of like this. The lowest spot on it will be the bottom part. Unless it's been flipped upside down. Would you agree that this parabola from our last test has been flipped upside down? So then it's looks like this. True or false, my final parabola looks like that. False. What's wrong with it? Has to go up 8. Very good. So then it would be like that. Now that's my final parabola, that white one. And I'm just going to scribble this one out. And now, if they just asked you, is its vertex its minimum? Or is the vertex its maximum? It'd be a pretty easy question now that you see it, right? Would you agree that it's the maximum? All right. So you can tell this, and this negative on the outside, his name is Max. See what I did there? If there's a negative on the outside, then it's going to be an upside down parabola, and it has a maximum. And if there isn't a negative on the outside, then it must have a minimum. So a normal parabola that doesn't have the negative, I don't care what these numbers are. That doesn't matter at all. If there's no negative in front, it's a right side up parabola. And therefore, it would kind of look like this, and therefore, its low spot would be a minimum. If there is a negative, then it's upside down, and its vertex would be a maximum. So if you start seeing that as max the negative, it'll help you. Otherwise, you got to take a second, sketch it out, go, oh, it's an upside down parabola, therefore it's a, or you can just see a negative in the front and say, oh, that's a max. If there isn't a negative, it's not a max, which means it's a min. All right, so you tell me, is this parabola right here? I know you're thinking, what's the vertex? That's not the question. The question is this going to have a maximum or a minimum? Minimum. How about now? It'll have a maximum. All right. Okay, you've learned everything that you need to know for today. So now's the part where you've got a Schoology quiz. You always get 2 tries on it. After the first try, you get the answers. So the reason that I give you 2 tries is if you get a sucky score on the first time, you can try it again, and then you'll get a better score, after you've seen what all the answers are, right? So I also know if I don't give you the answers, a lot of people are going to be like, I got it wrong, but I don't even know what I did wrong. So I need to give you the answers, but I can't give you the highest of 2 tries, because otherwise some kids will type in crap, get all the answers, and then just copy them all in, instantly get a perfect paper, and not learn anything. You get what I'm saying? So you get 2 tries. Try hard on the first one, though, because you're going to get an average of your 2 tries. All right. That's all I have for you for the video for today.